Hey, how's it going? Mr. Farrell here, and I just wanted to make a quick video tutorial on how to use the Coat PBL spreadsheet as you all are working on your Coat PBL and some of the problems and work that you have to do for that. So let's start off by seeing where to access it. So we're on our class page. This is 4th hour. We'll go to the weekly course assignments, go to quarter 2, and access the November 8th folder. All right, here we'll see our Coat PBL spreadsheet as well as a couple of other assignments that need to be completed. So we'll click on the spreadsheet. All right, open that up. All right, this gives us access to the spreadsheet, but we're going to go to File and make a copy of that because we will need to access that ourselves. You can click OK. It'll make your own copy. All right, and open it in a new tab. Now, I already have the Coat PBL spreadsheet pulled up here, so I'm not going to make a copy myself. All right. And let's go ahead and open one of the assignments as well. So we're going to go back to the November 8th folder. We're going to come here to Coat PBL worksheet. All right. And we're going to click on this to open up the Coat PBL worksheet. Click on that link. All right. So now we've got the worksheet we're going to be working on and our spreadsheet. Okay, so first let's talk about some of the stuff we see on this spreadsheet. So we have a table here. In the table, in column B, you'll see all of the different materials you can make your coat out of, from aluminum to clay, copper, milk, concrete. You can make your coat out of anything. All right, now each column tells us some particular important values about the material. So we have the specific heat capacity of the material, the thermal conductivity of the material, and the density of the material. I'm going to include the cost of the material per pound just so that you can use that in figuring out some information about the coat, but that will be added later. All right. Now, if you don't know what the specific heat capacity, thermal conductivity, or density are, what do they mean? You can read these boxes over here to kind of jog your memory about what we've been talking about in class, okay? But these are those values for each material. Now, we're going to use these values in a spreadsheet to figure out how long a person wearing a coat made of this material would be able to stand out in the cold before they experienced hypothermia or began experiencing hypothermia. All right. So to make that clearer, let's go ahead and switch over to the body temperature versus time tab on our spreadsheet. Now here we've got some numbers and some boxes. Okay. Let's go ahead and take a look. So you will not change these boxes over here on the right. This is the outside temperature, which is going to be set to 0 degrees Celsius, which is negative 32 degrees Fahrenheit or freezing temperature. Underneath that, you see the time step in minutes. So this is as the person stands outside, every minute that passes, how is their body temperature changing? So we don't want to change this. This is just going to stay as 1 minute. Down here you see the total weight of the coat in pounds. This will be automatically updated depending on the materials that you list over as your layers of the coat. Okay, so you will never need to change any of these boxes. You can leave them as they are. Now, over here you'll see the coat, so how many layers the coat is made out of. This coat is made of 3 layers. And then for each layer, you see these values that were on the other spreadsheet, okay, or the other tab. All right. Each of these values gets plugged in to one of these boxes. So we're not sure what materials were currently being used to make this 3-layer coat, but we know that layer 1's specific heat capacity was 3640. Layer 1's thermal conductivity was 0.39, and layer 1's density was 750. Because as you can see, CP, K, and density are listed on this sheet. So all specific heat capacity values, CP, are in the first column. all thermal conductivity values, lowercase k, are in the second column, and all density values are in the third column. All right, and you'll just plug them in based on what material you're using. So let's go ahead and delete these. These are the only boxes on the spreadsheet that you will be changing. All right, all the other boxes are either going to stay the same or update automatically as you change the materials. All right, so let's go to our classwork. Now, on this sheet, it's showing you that you're going to be making a 1-layer coat, 2-layer coat, and a 3-layer coat. You're going to make 10 1-layer coats, 10 2-layer coats, and 10 3-layer coats. And the goal is to see at what time would the wearer experience hypothermia. Okay, so we're going to make a 1-layer coat and see how long until the person wearing that 1-layer coat would experience hypothermia. So we're going to go ahead and we'll do problem 2 first, just because beef is a bit easier to work with than aluminum as we begin working with this sheet. So let's go ahead and find the values for beef, all right, to make our coat out of. So for starters, we want to change our layers to 1 because this is a 1-layer coat. Now let's go over to our specific heat capacity. All right, now if we switch our tabs down here, let's find beef. All right, so the specific heat capacity of beef is 1670, thermal conductivity is 0.44, and the density is 1033. So we're going to go over here and we're going to say for layer 1, the specific heat capacity is 1670. Now we're not going to put any numbers in for layer 2 or layer 3 because this is a 1-layer coat. There is no layer 2 or layer 3. So now we're going to go to layer 1 thermal conductivity. That's 0.44. Again, there's no layer 2 or layer 3 because it is a 1-layer coat. All right, and then we're going to plug in beef's density, which is 1033. And again, no density for layer 2 or layer 3. All right, now as you see the spreadsheet automatically updated, we can now see that the total weight of the coat is about 2.8 pounds or 3 pounds. All right, we're not going to write that information down. The important information to gather is from our table here below. So from the headings on the table, you can see that it is telling us the time and the body temperature. Now the body temperature starts at 37 degrees Celsius because that is our body's normal operating temperature, 37 degrees Celsius, which is 98.6 degrees Fahrenheit. Okay, and we see that is at 0 minutes. So what we're going to do is scroll down our body temperatures until we begin to experience hypothermia. Now, hypothermia begins to occur when your temperature reaches 35 degrees Celsius. Now, when we are looking on the spreadsheet, we don't want to just look for the number 35 because 35.9 is still above 35 degrees Celsius. So the body hasn't reached hypothermia yet or begun to experience it. So what we're going to do instead is we're going to scroll down our body temperatures until the temperature drops just below 35 degrees Celsius. So as soon as you see 34.9, that is the time you want to record as when the wearer of the coat is beginning to experience hypothermia. All right, because anything above 34.9, any 35.2, 35.5, that is still above 35 degrees Celsius, and so the wearer is not at that time experiencing hypothermia. So on this table, we drop below 35 degrees Celsius at 32 minutes. So at 32 minutes, the wearer of this coat will begin experiencing hypothermia. All right. Now, the important part to record is the time, okay, because we want to know the time at which the wearer of the coat would begin to experience hypothermia. So we're going to go over to our worksheet next to beef and write 32 minutes. All right. Now, let's go ahead and do another example. So problem 12 is showing us apple and cellulose, okay? So let's go ahead to our sheet, and we're going to do a 2-layer coat of apple and cellulose. So let's delete these values, all right? And we're going to change this to a 2-layer coat. Now, as you see, some of these boxes look a little crazy. That's because we're making a coat of 2 layers, but there's nothing in the layer 1 or layer 2 boxes. So the spreadsheet is just showing us that there's nothing written there. All right, so let's go ahead to our constants tab. We're going to find Apple, which is 3640 for specific heat, 0.39 for thermal conductivity, and 750 for density. So let's type that in, 3640, 0.39, and 750. All right. And we put that all in the layer 1 boxes because our first layer is Apple. Now our second layer, layer 2, is cellulose. So let's go back and look up cellulose. All right, so that is 1400 for the specific heat, 0.23 for the thermal conductivity, and 1500 for the density. All right, so 1400 for thermal conductivity, 0.23 for 1400 for specific heat capacity, 0.23 for thermal conductivity, and 1500 for density. Now again, we don't include a layer 3 because we don't have any, it's a 2-layer coat. There is no third layer. Now you can see the weight of the coat automatically updated. This coat is about 6 pounds in weight. And we're going to scroll through our body temperature and time table again to see when the body temperature drops below 35. So again, as soon as we see 34.9 degrees Celsius, we know the wearer of the coat is experiencing hypothermia. So let's scroll down. All right, we're in 36s, 35s. All right, we're still looking for that first 34. All right, now here we passed it just a little while ago. So the body temperature is still above 35 degrees Celsius at 59 minutes, but at 60 minutes it drops below 35 degrees Celsius, is at 34.9. All right, so let's go ahead and write 60 minutes as the time at which a wearer of an Apple and cellulose coat would experience hypothermia. All right, now we're gonna do one more example. Okay, now as you can imagine with the 2-layer coat, you do the same thing for the 3-layer coat. All right, for example, for problem 21, we've got an Apple, asphalt, and nylon 66 coat. So we would go to our spreadsheet, all right, and we would look up the values. We change our layers to 3. All right, now the first layer was Apple anyway, so we could keep that. But for the other boxes, we have to fill in information for the asphalt for each of these and the nylon, which is layer 3 for each of them. All right, now, again, notice that in the work between problems 21 and 22, the order of the layers is different. In 21, we have Apple, then asphalt, then nylon 66. In 22, we have nylon 66, then Apple, then asphalt. The order does make a difference, so you would want to make sure that Apple is your layer 1 in problem 21, and for problem 22, make sure nylon 66 is your layer 1, because that actually will give you different answers for problems 21 and 22. All right, so make sure you take into the account the order. Now the last problem I want to do is actually problem 1, which focuses on aluminum. So let's look up the aluminum values. So problem 1 is telling us to make a 1-layer coat of aluminum. So aluminum is 897, 237, and 2700. So we've got a 1-layer coat of aluminum, 897, 237, and 2700. Now the important thing to notice about this coat is that as you look on your table, your values begin to go crazy. If your values go crazy like this within the first 15 to 20 minutes, this is the spreadsheet telling you that the way heat is transferring in this coat is not conducive to a good coat. So you wouldn't actually look for a value where the temperature drops below 35 degrees Celsius. Instead, you would go to the spreadsheet and you would write, not a suitable coat, all right, or not a good coat. All right, so that should give you enough information to use to make your, or to complete your assignment. Let me know if you have any questions.